day. There is no explosion, no fireball, no smoke rising into the sky. Just a sharp crack of displaced air, followed by silence. Then, miles away, a target simply ceases to exist. Steel armor shatters. Concrete disintegrates. Theme. The impact arrives with such force that sensors struggle to measure it. No missile struck the target. No bomb fell from the sky. What hit was a solid metal projectile, launched by raw electromagnetic power. Traveling faster than sound, faster than most defenses can react. This is the railgun, and it represents one of the most radical transformations in the history of warfare. For centuries, weapons relied on chemical explosions, gunpowder, fuel propellants. Even the most advanced missiles still depend on controlled fire. Railguns break that tradition entirely. They replace combustion with electricity. Instead of explosive force, they use magnetic fields so powerful they can hurl metal at hypersonic speeds. When a railgun fires, it does not burn its way forward. It tears through physics itself. The idea of the railgun is deceptively simple. Two parallel metal rails, a sliding armature between them. A massive electrical current surges through the system, generating a magnetic field strong enough to accelerate the projectile down the rails at unbelievable speed. No explosive warhead is required. Kinetic energy alone does the killing. And at Mach speeds, kinetic energy becomes devastating beyond imagination. The concept dates back over a century, but for most of history, it remained impractical. Early railguns destroyed themselves after a few shots. The heat was extreme. The electrical demands were overwhelming. Power systems simply could not keep up. But modern warfare thrives on one thing above all else: energy. And as power generation, capacitors and materials science advanced, the railgun moved from theory to reality. In secret test ranges and naval laboratories, engineers finally achieved what once seemed impossible. Projectiles traveling at over Mach 6, targets destroyed from distances exceeding 100 miles. Accuracy so precise that the projectile could strike within meters at extreme range. And all of it without explosives, without fuel, without missiles. The implications were immediate and terrifying. Traditional naval guns are limited by range and shell power. Missiles are expensive, vulnerable to interception, and limited in number. Railguns change everything. A railgun round costs a fraction of a missile. It cannot be intercepted easily. It does not emit a heat signature like rockets. It arrives so fast that enemy defenses may not even detect it before impact. Imagine a warship. Armed with a railgun, it carries hundreds of solid metal rounds, instead of a limited missile loadout. It can strike enemy ships, aircraft, or land targets from extreme distances. It never runs out of propulsion, because electricity replaces fuel. As long as the ship has power, it has firepower. This is why global militaries took notice. The United States Navy invested heavily in railgun development, envisioning destroyers capable of firing projectiles across entire regions. China followed with its own electromagnetic artillery programs, even testing railguns mounted on naval vessels. Russia explored land-based and mobile railgun concepts designed to punch through armor and harden bunkers. Each nation understood the same truth. Railguns could render traditional defenses obsolete. At hypersonic speeds, armor becomes meaningless. Explosive reactive armor cannot react fast enough. Active protection systems struggle to detect the incoming round. There is no warhead to detonate prematurely. The projectile doesn't explode. It simply arrives with such force that matter behaves like liquid. But speed is only part of the revolution. Railguns redefine logistics. Conventional artillery requires complex supply chains for explosives and propellants. Railguns require power and metal. In future wars, energy will be easier to supply than explosives. Mobile reactors, advanced batteries, and ship-based power systems make railguns uniquely suited for prolonged conflict. They also change the psychology of warfare. There is something deeply unsettling about being attacked by an invisible projectile with no warning, no sound, and no chance to react. Soldiers have been trained to listen for incoming fire, to detect missile launches, to respond to explosions. Railguns remove all of that. By the time you realize you are under attack, the damage is already done. Yet railguns are not without challenges. The immense forces involved generate extreme heat and wear. The rails themselves degrade with each shot. Power requirements remain enormous. Firing a railgun is not just pulling a trigger. It is unleashing a controlled lightning storm. Engineers continue to battle erosion, cooling, and energy storage limitations. But progress is relentless. New composite materials are extending rail life. Advanced cooling systems are allowing faster firing rates. Compact power modules are making mobile railguns feasible. What once required a massive ship may soon fit on land vehicles, coastal defenses, or fixed installations protecting entire regions. And then there is space. Railgun technology is perfectly suited for orbital warfare. In space, where there is no air resistance, a railgun projectile can travel vast distances with terrifying efficiency. Satellites, spacecraft, and orbital infrastructure could be destroyed by kinetic strikes, launched silently from hundreds of kilometers away. No explosion, no debris cloud, just precision destruction. This raises a chilling possibility. Wars may soon be fought, not with missiles screaming through the sky, but with invisible metal rounds launched by electromagnetic force, striking before diplomacy can even react. Force. As with all revolutionary weapons, railguns force a strategic shift. Missile defense systems are designed to track heat, propulsion, and trajectories. Railgun rounds offer none of those cues. Defense becomes harder. Reaction time collapses. Offense gains the upper hand. Some military thinkers believe railguns could reduce reliance on nuclear weapons. Why use a nuclear strike when kinetic energy can deliver devastating results without fallout? Others argue the opposite, that railguns make preemptive strikes more tempting, increasing the risk of rapid escalation. What is certain is this: the railgun is not just a new weapon. It is a new philosophy of war. One where energy replaces explosives, where speed replaces intimidation, where physics itself becomes the battlefield. 2. The wars of tomorrow may be fought by machines, commanded by algorithms, and decided by weapons that fire at the speed of lightning. And when that future arrives, the sound of war may disappear entirely. This is WarTech Frontier, and the age of electromagnetic warfare has begun.